Okay, so this is where we're going to start. We got to start somewhere, right? So we're going to start with really basic stuff. These are key words, and I'm going to kind of explain them. And if, like, when I explain it, if you already knew it, then you'll be good. Okay, but while I'm explaining it, if you didn't know it, then maybe you should write it down. Okay, so yeah, I mean, you can write down the keywords, that's fine, but those are the things just kind of for me to talk about. We have to start somewhere, so we're going to start with like a graph, but we're not going to graph stuff today. I hope not. I didn't preview it, but if we have to graph, we will. I don't think we will. Okay, so everything that you see there is like, you know, it's like this guy right here. This is my graph. Okay, so, but our people online can't see that. So maybe hold patiently. That's great. That's cool. Search. Yay. Okay, so there we go. Does everybody know that the x-axis is right here? It goes left and right. You should know that, right? If the first value is positive, it goes to the right. If it's negative, it goes to the left. Big whoop. Hey, that means that up here, that's the y value, or sorry, the y-axis. And if the y value is positive, it goes up, and if it's negative, it goes down. Just saying. The origin is right here in the middle. So maybe a couple of our foreign exchange students, I don't know if you guys have used that word, origin, but it's just right in the middle, 0, 0. The quadrants, remember, this is the only time really that I will use, I don't know, I guess I could start using Roman numerals more. But do you use Roman numerals a lot? Maybe in English class, making an outline or something. But this is it. And I don't know why it's always Roman numerals, but it always is. So it always will be quadrant 1, quadrant 2, quadrant 3, and quadrant IV. She's back. Was it a successful trip?
I think so. This one turns on.
So it just didn't, huh?
It turned on. It was like on the charger, but
Then afterwards, nothing?
yeah.
Okay, so in quadrant 1, it's always what? Positive, positive. In quadrant 2, it's always negative, positive. In quadrant 3, it's always negative, negative. And in quadrant 4, it's always positive, negative. Right? You right. You right. The x coordinate is always first. The y coordinate is always second. Any questions on that first slide? It's pretty basic, but I thought I'd better talk about those. Don't worry, it'll get tougher. Like you guys are like, psh. Oh, don't worry. It'll get more fun. Usually for the Pledge of Allegiance, I sing it because I came up with my own song for the Pledge of Allegiance, but I'm not going to this year.
Why not?
Because nobody last year sang along with me.
Well, maybe we will. This is a different class.
No, it's the Pledge of Allegiance. I can't write it on the board. No, it's all the words. I just put it to music because I think it's more fun to sing the pledge than to state the pledge.
Well, I mean, we don't.
I really think that I could become, you know, pretty famous because, like, Susan B. Anthony or Francis, was it Francis Key Scott? Is that who wrote the song? I don't know. But anyway, you would remember that I wrote the music for the Pledge of Allegiance. It's very patriotic.
I think we should sing it tomorrow.
I might start. No, I might start maybe later. I'm trying to stall for. Are you good?
Yeah.
Okay, good. Here we go. Next. So now we're going to talk about putting lines on a graph, but gosh, I don't know if I really feel like graphing today, so we'll see. But you're used to seeing y equals mx plus b. Some of you people that are an A-type personality might like ax plus by equals c. Remember, probably for the first quarter, it's going to just be a review of Algebra 2, but harder. So maybe not a review. I mean, you should know everything that I show you.
What does that say? Because if C equals 0, then what's that? What's that line?
The line goes through. A lot of times I abbreviate the word through because there's just a lot of letters in the word through that I don't know that we really need.
Make it a theory.
Is through, T-H-R-U, an actual word? But is that just hyphenated? It's hyphenated.
It's circle. So it's like A X plus B.
My handwriting is perfect. Perfect handwriting. How about glasses? It's okay to have glasses. Do you want to leave them in my room?
No, they like hurt my eyes. And like right here. They always fall off.
That's okay. Just bring them to my class. I'll keep them in my desk. Bum, 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 bum. No. Lunch is my favorite class to teach. I love my 4th hour class. No, don't have a 4th hour class. I don't know. Yeah, I mean, it's sure. I just like the variety that teaching gives me. Kylie just texted me. Patience. Are we doing anything today? She's going to hear that. Patience, Kylie.
She did say yesterday that you didn't post anything for them to do, so she didn't know it's real.
She got her book. I texted her. She got her book yesterday. Patience, Kylie. We're in the middle of class. Okay, are we good with that slide? So let's talk about this. Y equals mx plus b, that's slope-intercept form, right? Slope-intercept form, because m is the slope and b is the y-intercept. We can talk more about what do you guys know what the y-intercept is? It's like if you had a line, it's where the line crosses the y-axis. That's the y-intercept. What's the name of this form? Ax plus by equals c. What? Standard. Standard form, boring form, whatever form. Some people like it better, and then I say, hey, how do you find the slope on this? And then some people are like, isn't it like negative a over b? And then some people are like, isn't it negative b over a? And I'm like, why don't we just write it in this form? And then it takes out the guesswork. Which one is it? If you're, what is it? Negative b over a or negative a over b? You'd still have to write this puppy into slope-intercept form. So you'd have to still just get y by itself. So then I'd move that guy over. Don't worry about the c, because the c is just there. But I'd move that over, and then I'd have to divide by b. So then it'd just be negative a over b. But that was extra work compared to y equals mx plus b, which has its own song. Y equals mx plus b. In standard form, instead of a c, if that was a 0, the standard form, so if it was just like 5x plus 6y equals 0, then it would go through the origin, the middle, okay? If x is gone, so if there's no x and it's just, and if there's like this part isn't here, the ax isn't there, so if x is gone, then it's a horizontal line. So if it's y equals 5, it's a horizontal line at 5. And then if y is gone, it's a vertical line. So if it was like 5x equals 25, it's going to be a vertical line. Okay. So any questions there? That's just some graph stuff. Maybe I haven't graphed anything yet. I've talked about graphing. Me and Tori talked about graphing yesterday. How she loves it. Hang on. There we go. Distance equation. I'll text her back. Yes.
Yes.
Yeah. And she'll hear that too. And she'll hear me saying, and she'll hear that. I know. All right, the distance equation. I abbreviate a lot of stuff, but maybe for foreign exchange, I probably shouldn't. Distance equation. Then there's a fancy word, equidistant. Then there's midpoint, and then there's slope. I'll wait. There, I explain more to her.
What did you say?
Making video now. And now she's going to hear that too. And then when she listens to the video, she'll think that I'm making another video. But I'm not, Kylie. Okay, so we really haven't done much yet. The distance equation is where it's going to start getting a little tricky. Maybe the midpoint. Can you read everything?
Not the red.
Oh, y2 minus y1 over x2 minus x1
Read that again, Y2.
minus y1 over x2 minus x1. Your eyesight is pretty poor because my handwriting's awesome.
Okay.
She agreed. Oh, and these are triangles with one heavy side. So it's delta y over delta x, and sometimes, like in college, some professors like to use that stuff, and you're supposed to know what it means. It just means that, yeah. At least in math, the delta symbol like that just means change in. So in science, I imagine you could do delta, Fahrenheit or whatever. Yeah, the change in temperature. Okay, are you ready for this? So if I have a set of points, it doesn't, let's say I have 2 points just floating around. It doesn't matter which point I pick as x1 and y1 and x2 and y2. I could swap them, and this equation, well, all these equations would still work. Okay, so some people might work on a problem and you might think that they're subtracting backwards. No, it's supposed to be 5 minus 3 instead of 3 minus 5. You're still going to get, so long as you follow the correct pattern, you're still going to get the same answer. That's the cool thing. Okay, with the distance equation up here, you're never going to get a negative answer, would you? That would be bad for the distance. So for the distance equation, you're never going to get a negative answer, obviously, because you're squaring stuff. And when you square stuff, it becomes positive. If you square imaginary numbers, it's a different story, but not right now. Distance equation. Good? Okay. Equidistant means the same distance. Shocker? Or equal distance. So I know for a fact on one of the problems I want you guys to try today, it's going to say that there's 4 points and A and B are equidistant to B and or C and D or something like that. It's going to say that they're equidistant. So that means you would have 2 of those puppies and just put an equal sign between them. That's the hardest problem today. Let's see, I don't know if there's more. Oh, we have a lot of time. Okay, write that down. And this is the assignment that's posted, but don't even start thinking about doing that because we'll go back and talk about distance equation here in a second. And I haven't added any notes yet. You haven't got to see me do any live writing. Well, except for like X and Y. Tori, have you changed any flat tires recently? Have you changed any flat tires recently?
2 months is it?
That's crazy.
Yeah. You know, James missed her birthday class, so she had a flat tire. Popped her tire and loose.
But she does have a car.
It's not hers.
Oh.
Her grandma's. But she's
No, she's been on radio silent with me. Shrug. Okay. Do you remember what elimination and substitution are? Let's talk about each one of those, and then let's talk about the equidistant thing again. I'll go back to the slide that has the assignment on it, so don't worry about that just yet. Okay, so let's do first. Let's say that I had 2 equations like 2x plus 5y equals 15 and 3x minus 6y equals 11. Something like that, okay? And if I don't want to graph those guys to find the intersection, because that wouldn't be fun at all, I could do elimination or I could do substitution. Do you remember that? Should ring a bell. Okay, now I just made up some problems, some random problems, which means this answer, I'm certain, is not going to be pretty. But this guy, like if I graphed it, I could graph this guy as a blue line, And if I graphed it, I could graph this. Wait, how come I can't? I wanna change the, never mind. I could graph that line as a black line. I don't have a green option. Okay, and then I could say, hey, where did the black line and the blue line intersect? And that wouldn't be that fun because graphing, you couldn't even tell exactly where they intersect. So what you could try instead would be to either eliminate or substitute. If I'm looking at this problem, I don't think I want to substitute. Like I don't want to use substitution on this problem because there's no plane X or no plane Y. If this guy was gone, then I could say, woo, I could solve that for X and plug it into the top equation. Is this kind of waking your brain up a little? Okay, but it's not. There's a 3 there. So since that, like neither one of these equations can be simplified, I can't like factor out anything out of the top equation, and I can't factor out. I had to be careful on this bottom equation when I was writing it to make this 11 and not 12, because some people would be like, can't you factor out a 3? So I made it 11 because 11's prime. So what would my choice, like my wise choice be? My wise choice would be to do elimination. Do you remember this? So this guy's kind of a headache because if it's me, I'm just going to do something like this. Multiply that by -3 and multiply that by 2. Because I just decided on a whim to try to eliminate the X value. See it? So I got to have an opposite X of the same value. The top one's going to be -6X, and the bottom one's going to be +6X. So far, so good. So if I did that, this would be the top equation, would be this, this, that, and then the bottom equation would be this, that, that, and then you just draw your line and just add down. So the x's went bye, bye, bye. -27y equals -23. Oh, and of course y is some type of nice decimal. I have a calculator, so I'm going to figure it out. 23 divided by 27, I get a decimal of 0.85. Then what would I do? I'm not going to stretch this problem out much more, but what would I do with the 0.85? Plug it in, plug it in. Which equation, Mr. Blanchard? Doesn't matter. You choose. I guess I would go right here because it was easier for me to draw my arrow. And I could plug it in there and then solve for X. That's elimination. So we kind of woke up our brain there, right? Yes. Okay, now let's talk about equidistant because I kind of mentioned it, but I'm just going to make up one. It's not going to work. So I know that really bothers me that I didn't finish that problem either, but we got the gist of it. Okay, now let's say that I was graphing something. Okay, and let's say that I had some dots, 1, 2, 3, 4, 5, 1, 2, 3. Okay, so this guy is, I'm trying to make up this problem on the fly. This is 5, 1, and this guy is -2, 4, right? But my graphs are as sweet as my handwriting. Okay, this is point A, this is point B, and then we're going to say that C is equidistant from A and B. And I'm even going to make it a little easier. C is equidistant from A and B, and I'm going to say that its Y value is let's make it negative, I don't know, -6. I don't even know if this problem is going to work. I hope it does. We're going to find out. Are you ready? Are you confused? So am I, because I'm just making up the problem. Here we go. So here's what I know so far. I plotted 2 points correctly. Yes. And I called them A and B. And then I'm like, where in the heck do I put C? Where in the heck do I put C? Well, I know that the C value is floating 1, 2, 3, 4, 5, 6. That you can't do this, but I can. Hang on. Let's see if I can do this now. Look, here's C. And C's like, whoa, whoa, where do I go? But the Y value is -6. It can't move up or down. Its Y value is somewhere on this line, right? I just don't know where. But wherever I stop, when I draw a line from C to A and B, when I draw it from C to A and C to B, those puppies better be exactly the same distance. Oh, equidistant. Do you get that? So do you think that C would be, do you think that C would be over here? Do you think that from C to A is the same distance from C to B there? No. I can't put it over there either, because then CB would be shorter than CA, obviously. So I think it's got to be somewhere in here, right? But I don't know where. I wish I did. Okay, so here's what we're going to do instead. Actually, I'm going to make you go away. Wait, how come I can't? Can I? And then I want to. Okay, so I'm going to call C. What letter should I use? I don't want to use X. What? Z? C? You want to? No. Like it's going to be, no, C's cool, but then it's going to be something comma -6. But I don't know what the something is. I heard Q first. Can we just use Q? Capital Q? Yeah, because that's easier. Okay, so Q -6. So will we agree that I'm thinking that it's probably somewhere here?
Yeah.
I don't know. I'm guessing that those guys are, I don't know. CB might be a little longer there, but so maybe it's just a little to the left of that. I don't know for sure, but there's a way mathematically that I can find out for sure. Yeah, we still have 10 minutes. This is awesome. I've been waiting all summer.
Me too.
Just like I'm playing golf, playing ball with my dog, going on vacation, but the whole time thinking 1.1 notes pre-calc.
What are you going to do?
I'm going to play golf and pickleball, ride a golf cart. I know. Well, that's one of the reasons I picked teaching as a profession, because like I started off in aerospace engineering, which was cool. And I liked it, and I studied it for a year, but I was like, could I do it forever? But like with teaching, if I didn't like you guys, you're going to be gone in 50 minutes anyway. Every hour there's a change for me, so I kind of like that. It's just my personality though,
Like you give everyone a little bit of,
That's right. Spread out. All right, so equidistant. Are you ready? I'm going to go from Q6 to point A. All right, so I'm going to call this AC. And the distance of AC is going to be, you ready? 5 minus Q squared plus 1 minus 6 squared. Would you agree that that would give me the distance from A to C? Would you agree? I just used the distance equation. So I went from 5 to Q and then 1 to 6. So x2 minus x1, y2 minus y1, right? You're right, you're right. But it's got to be equidistant for BC. So here goes BC. Oh, wait, let me change colors. BC. Okay, BC would be negative 2 minus Q and 4 minus 6. Did I lose anybody? Oh, hang on. I can extend that page. My bad. There. Yes?
Isn't the 6 supposed to be negative 6?
Did I mess up?
I don't know.
Oh, yeah, thank you. Bonus point. So it's 5 minus, or it's 1 minus negative 6. And then down here,
Couldn't you put 1 plus 6? Okay.
Negative 4.
there. But if I wrote a plus, then someone would say, why did you write a plus? It's okay. Thank you. Way to catch that. I had it here. I didn't know there. Somebody must have sabotaged this problem. Now, what do I know about these two distances? They must be equal. And this is where the fun's going to begin for you guys, because you're going to have a problem just like this. And it is fun. I wish I could change this to, okay. So that means that this guy, oh, did you see that? Hang on. There we go. That means that this guy, 5 minus Q squared plus 1 plus 6 squared, has to equal this guy, negative 2 minus Q squared plus 4 plus 6 squared. Would you agree? Yeah? So would I. Okay, so that's what equidistant means. It means the same distance, but it means the same distance formula. Like they gotta equal the same thing. So I had to do the distance formula once, and then the distance formula twice, and then set them equal to each other. But this is where, like, your past algebra that we haven't talked about comes into play. And I might even say the F word today in class. Get ready. And it's not fun. Okay. How do I get rid of, on that green equation, how do I get rid of the square root symbols? It's an equation. How would I get rid of the square root symbol? Not square root it, square it. So I'm going to totally illegally write this mathematically, but just follow along. I can square the left side, and I can square the right side. That mathematically, what I just wrote is kind of incorrect. I guess it really should look like this. Yeah. But in my mind, I just thought, hey, I better square both sides. Well, what does a square and a square root, what do they do to each other? They poof. See you later, square and square root. And they're like, hey, wait a second, nope. They're like matter and antimatter. Whew, gone. So the green side is just 5 minus q squared and 7 squared. And the right side is negative 2 minus q squared and 10 squared. Well, by the way, I'm doing like the most hardest thing in the world on day one. Because your brain needed a jolt, didn't it? I am about ready to say an F word that has 4 letters. I'm gonna say it. I'm gonna say it in class. It's gonna be recorded. It's gonna be shared. Are you ready? Foil. Shucks. I have to foil. I have to foil minus 2 minus q, negative 2 minus q. I have to foil that. And I have to foil 5 minus q. Do you remember how to do that? Yeah, that's why I said it's an F word. Fun. Okay, obviously I could move the 49 over to the right by subtraction, like this would become 51 over here, but I would still have to foil that dude, and I would still have to foil that dude, and then try to solve the equation. And that's another fun word, or another F word, fun. So I've kind of teed up, like I put the ball up for you. Now I want to see if you guys can like hit it. So you're going to have a problem just like this. And this is kind of like your guidelines for what you're going to do for that problem. Okay, that's the hardest problem, I promise. We did it. We did it.
I forgot how to foil.
Okay, thank you for asking. I have 2.5 minutes. Here we go. Are you ready? Here's the issue. If I write 5 minus q, I have to write it twice, 5 minus q. Okay, and then this 49 is going to go over there, right? And then this guy's going to be negative 2 minus q and negative 2 minus q. And then there's going to be, what is that, plus 51. Handwriting's looking sweet. All right, here we go. First outer, inner, last. First outer, inner, last. 25 minus 5q minus 5q plus q squared. And then this puppy would be 4 plus 2q plus 2q plus q squared plus 51. There, foil. Fun. But look, you're thinking, dang, that's got a q squared. That's going to be really tough. Well, there's a q squared on both sides. If there's a q squared on both sides, what happens to the q squareds? I'm so glad you picked the letter Q. All right, so here is the assignment in red. I just posted the book online. Number 33 is the only odd one that you would be able to find the answer to in the back of the book, but I posted the odd answers also on Google Classroom. Try to do them. Don't freak out if you can't. Don't come in at 7:30 in the morning. All tomorrow, we're just going to go through homework. Okay? Adios.